Good evening, everyone. Warm welcome back for a warm welcome back for those who joined yesterday, and those who are joining new. Welcome again. So today I'm going to talk about career opportunities in data and analytics. But prior to that, I will just do a brief introduction. My name is Santhosh. I'm part of the technology and innovation team at Standard Chartered. I have around 20 years of work experience in the technology domain. My key areas of interest are data analytics, machine learning, robotics, and digitization. So, thanks to NPTEL for this opportunity yet again, and I hope we make the best use of the platform provided. So, without much ado, let's move into the presentation. So, uh, Standard Chartered Bank is a British multinational bank. It has a rich heritage of 160 years. A small trivia for you: though it is headquartered in London, it was formed as a result of the merger between Standard Bank of South Africa and the Chartered Bank of India and China. So basically, Calcutta, Mumbai, and Shanghai were the first branches where Chartered branch actually operated. So actually, it is something that probably not many of them would be aware of. Right. So we start from where we left yesterday. So for those who joined yesterday, it might be a good connect. But for those who did not, fret not. So that's why I'm trying to take the feedback from yesterday and I'm trying to dovetail to how it links to what I'm going to talk about today. So yesterday we spoke about actionable insights from data, and do we have the right people? And having the right people has to do a lot with the skills and the knowledge that you have. So we'll talk a lot about that today. We'll also talk about how having access to every member in the firm is more easy said than done. Meaning to say, what are the challenges in governing that? Then yeah, so we spoke about the balance between speed and cleanliness of data. We'll talk a little bit about that. New technologies. How does it play in your overall career path? We'll talk about that, and definitely all these aspects which is tied to your career progression and skills needed to be successful in this domain will be discussed today. So we start off with the first slide, which I've named it data lasagne. So it just is so easy to kind of look at it and then understand. So there are three components to a data ecosystem, if I may say so. So the first component is the data infrastructure or the data engineering layer. This is very fundamental. So you need something for the rest of the components to work. So data is the foundational layer. So data infrastructure, or call it data engineering or data platform, that's one component. The second component is how do you actually take this data and create insights and value and generate meaning out of it. So that's where the analytics, the machine learning, the science, etc. is done. And that's the second layer. The third layer is the governance part, which covers all these three. So in effect, in the field of data and analytics, there are only three career paths in simple terms. One, which you can be a data engineering guy or a girl, or you can do data governance, or you can do data science. And those are the four major parts. So data engineering, data governance, data scientist or data analyst. Scientist and analyst, for sake of brevity for this presentation, will be interchanged. But yeah, look at a data scientist as a senior version of a data analyst. Both are equally important. And I also wanted to talk about yet one more ecosystem that is getting turbocharged, which is data startups. So while there are three parts, the fourth one is also equally rewarding, and we'll talk a little bit about that also. So these are the four major career paths. If anyone wants to make a choice or a career in data, should be aware of. We'll start with data engineering. So what does a data engineer do, right? So it's pretty straightforward. He collects data from multiple systems, and he or she actually stores the data, and then processes it. Very simple, right? So on the left-hand side, if you see, you have various source systems. So it could be streaming data, it could be log data, it could be from retail lending data. So it could be department data. It could be data that's even uploaded in Excel. So it is format agnostic. So you should be able to consume any form of data. That's the one that's on the left. I've put in a column called data lake, but essentially that's to tell you whether you call it data lake or data ocean or data swamp, whatever be the terminology, but that's where your data is going to be stored. Obviously, you need to put rules around it, a time view, an end of day view, and a week view. So for those who attended my presentation yesterday, I was talking about all data being real time, which is so very true. I think most of the data and most of the analytics in future will be real time and event driven. But there will always be a need for end of day view or a weekly view. And the reason that has not to do with the fact that you can't get real time data. There will always be financial reconciliations or adjustments that are done. And those adjustments and reconciliations may take time to get posted. So as a result, people from the finance department or people who want data to be reconciled, say to the fifth decimal, might need to wait. So they can't obviously use real-time data, which might be true, but which might have an adjustment flowing in. So that's why we call it the relevancy views. So it depends. So if you're a consumer who doesn't need financially reconciled data, you should be working off the real-time data. The last part is the self-service view. So self-service, while many data engineering people would be saying, hey, can I not do reporting, or can I not use SAS or MicroStrategy or Tableau or Cognos to generate reports? In my view, those are not the data engineering related tasks. Those are the view that belongs to the purview of the data analyst or the data scientist. So from a data engineering perspective, I call it a self-service data access, meaning to say you should be able to provide the data, structure and model the data. The end user should be able to consume it in the form and shape they want. Right. Now let's peel the onion a little further and let's understand and this is always an often asked question, what are the skills or what are the languages that a data engineer should have? And I kind of get this pretty often. So when I meet people, so the first I kind of on top I've listed some common programming languages that you should be aware of. So Python is number one. Python is number one. Java, Scala, and if you have, it's not necessary you should know all these, but even if you know one or two, that'll be a huge advantage. What is very important is your proficiency levels, right? Then when you go down to the next one, you have the first phase, which is around collection and ingestion of data. I have listed down around 3 or 4 for each domain. For collection and ingestion, it can be Apache Kafka, or it can be FluentD, or Mbulk, or Logstash. So these are, while people sitting watching this might think, hey, these are very niche, the reality is the world is moving towards an open source based architecture. So meaning to say, most of what I have listed these are not COTS, which are not commercial off the shelf software. These are open source software, and that's where the world is heading to. So if you have, say, a skill in Oracle or ETL, which was the old traditional way of doing data, fret not, but it is important that you upskill yourself. So it's important that you understand that the world is going to be open source based. The second column talks about what kind of stored processes that you should be aware of again. So now, to be very honest with you, it's all about cloud. So Amazon Redshift or your S3, Azure S3 or Google BigQuery. I've put HDFS there. and for again, it is a dying art, but it is still available. So it's not necessarily out of vogue, but I wouldn't recommend HDFS as something to specialize now. It's good to know, but if you're just going to start off your career, I wouldn't recommend HDFS. So you try to focus more on the cloud native form of storage, which are NoSQL DB, like MongoDB, those or Cassandra, those that's where the world is heading to, right? And then you have towards the end, which is needed for processing. So you have a whole suite, which is Spark, and then which is your ELK. So ELK stands for Elastic Logstash Kibana. And Elastic is also very interesting, right? So it is Elastic as a tool is again from Apache, from the Apache stable, and it's built on top of Apache Flume, which itself is an open source. So Apache Elasticsearch is built on Apache Flume. So it's very, very powerful, and it uses a concept of inverted index to search for data. So why I talk about all these is, while Scala, Python and all are traditionally known, not many people actually go through the nuances of these languages. So it's very important that if you plan to have a career in data engineering, again, the technical part of doing data science, then I would suggest you should be familiar with the tools that I've listed there. And if you are, good on you. But if you're not, you need to equip yourself with this. So we looked at the tools, and in this slide, I'll talk about what are the skills needed. Tools and skills are two different, right? So tools is what are the tools is basically your awareness of your language skills, your coding skills. So the first, whenever you go to any technical presentation, they talk about good coding skills. And I want to debunk that myth. I strongly believe that good coding skills is a given, in the sense that coding is equivalent to speaking English, and that's what is going to happen in the future. So meaning to say, you should know coding in some form, shape or size. What is lacking today is deep engineering skills, and I emphasize on the word engineering. Take the example of, we spoke about Elastic, and you saw in the previous slide how it was all an open source architecture. Most of these open source architecture are siloed in nature. So meaning to say, how will you take, say, Elastic and integrate it with S3? So a simple point, right? So it's not about, some coding is all about having a set of good skills to take a set of rules, apply it to an application and generate an output, which is not bad. But what is missing today is deep engineering skills. And if you want to be truly successful, I think this is where the future is going to, and you need to start thinking. You cannot be a programmer anymore, and because there are a dime a dozen, as you're aware, India and China produce the maximum number of programmers every year. But for you to stand out, differentiate yourself, and for you to stand out from the crowd, you need deep engineering skills. Again, you need to be pretty fluent with open source technologies. So historically, for those who began their careers at the same time as mine, so the big players were Oracle, C, C++, Java, and you had only 3 or 4 big languages you needed to know. And if you knew Unix and C and Java and Oracle, you were considered C++ to add. You were pretty much home. But the world is changing, and it's changing rapidly. So open source is something that is very much in vogue, and I would encourage you to start embracing open source software. It makes life easy, like Scala, so easy to learn. So if you are a good developer, or if you have a little bit of development experience, picking up open source technology should be a breeze. The other thing is just not to be fluent with open source. You should have a keen passion to contribute back to open source society, because open source is all about software being available for free, which everyone can harness and use. So you should have the passion and the heart to give back. So it should not be a one-way street, because only if you give back, the movement can continue to grow. So if you're just going to take fair game, you might benefit out of it. But by giving back, you also learn. So if you contribute back to open source, then it also means that your footprint is there in the software. And contributing is no mean feat. the people who sit in the Apache PMC, which is in the committee, on a code committee level, they are really, really smart people. So if your code is accepted by those guys, and if you contribute to any open source software, it's a fantastic achievement. And those are the kind of skills that we look when we also try to hire. We spoke about CI/CD yesterday, again integration, testing, and delivery, but you should also understand how it works in a data pipeline, right? So how does this whole flow happen seamlessly? A good understanding of microservices and APIs are necessary, and so that really will help you. And I couldn't emphasize, I think I've spoken about cloud quite a lot, but you also need to understand cloud architecture, because obviously while you'll have NoSQL DB and other modes of storage, familiarity with cloud architecture is a must. It's no more a luxury, it's a must. So till now, we've spoken about the skills. What we've seen thus far is the skills needed for data engineering and the technologies that you should be familiar with. Now we'll move on to the governance framework, the data governance framework, right? So this, for people who are familiar with the data landscape, the governance is like the policeman, right? So people run away at the sight of policemen. So it's not a glamorous job, but I think it's extremely important. It's a very critical function, and if you don't pay attention to it, many organizations have paid a huge price. So I think it's very important to give a lot of respect for this and understand what happens within a governance framework. So the data governance framework has multiple parts to it. I'll talk about a couple. I'm not going to go through each one of them. So let's take data policy management. So data policy will talk about what are the policies that I need to apply for the data, meaning to say, who is identified as the data owner? What are the critical data elements? So if you have a file, say a core banking file, there should be an owner from the business side who actually owns this data, because they are generating the data. So you should have an owner for the data. And he or she should also, you should work in correlation with them, with that person and their team to identify what are the critical data elements and why is this critical data elements needed. Take a core banking file. It might have 1,000 or even 10,000 elements, and it's just not possible for you to make sure that every element is accurate every day. Yeah, you can do profiling and you can do imaging. There are a lot of things, but it's extremely time consuming. So from a governance perspective, you probably will focus on what the customer ID, customer name, customer address, the balance. So if you can identify, say 10 to 20 or 30 critical data elements that are used for regulatory reporting or which is used for financial disclosures, those become your critical data elements. And that you have a hard lens to it and keep monitoring it closely. So data policy management is all about dealing with those kind of processes. It's also about identifying what are my personally identifiable fields, what are fields that are very critical for financial reporting, and deals with all those kind of things, right? Data security, we'll talk about that. So data security management talks about making sure, and this is where I was saying, do you do tokenization, do you do encryption, or do you do masking? What are the policies that you need to apply for the data? Because obviously some of the data is sensitive. So how do you handle sensitive data? Even within an organization, not everyone should have access, though I told you everyone should have access to data. I kind of annotated it with the statement that everyone should have access to the right levels of data. So even within an organization, for example, I shouldn't be aware of the other person's say age or salary, so stuff like that. So how do you make sure that while I have access to data, the rest of the data is masked? So those are how you enforce those policies and how you apply those policies. Yeah, data operations management is also about making sure every day is your data flowing seamlessly. So if you're, say for example, you get 100,000 files on a daily basis from source systems, are you making sure all these 100,000 files, say with 1 million fields, are shipped to you into your data lake or data reservoir in a proper manner? That's data operations management. So as I describe it, you must be thinking, wow, this sounds so painful. And the reality is, yes, it is painful, but it's, like I said, very, very important. And we'll talk about it. There are 3 maturity levels that we typically associate with reference to data governance. One is tactical, the other is strategic, and the last is pervasive. And I have to tell you very honestly that most of the organizations in the world, most, including Google, who were recently fined for a data breach, right? So they were for not following GDPR, um, so the global data privacy regulations principles. So they were fined 58 to 60 million dollars. So point I'm trying to tell you is, as much as the importance is there, it's pretty unfortunate that most of the organizations are not at a level that you can call yourself that you're in complete control of your data. This also has to do with the fact that data is spread everywhere and can be accessed by multiple people. So I would rate most of the organizations within either being a tactical or a strategic level. So pervasive is a utopian state, but that's what people should aspire for, where automatic reconciliation, automatic profiling, and if there are gaps, it's auto thrown up. You have people who are alerted if there's missing data, and the rules and policies are enforced. You have identity access management for each data. So if you have a policy that's set for you to access one set of tables, that policy is then grandfathered if it needs when you move roles. So all these kind of principles, policies, which is extremely vast, is what pervasive is all about. It's not that tactical and strategic is bad, but I'm saying the level for pervasive is pretty high. So we spoke about data governance, right? So why is it so tough? And let's talk about some of the challenges, right? So one of the issue is there is no global standard, and that's true for any organization. And I'll take a banking example to talk about. So within the retail bank, you might have a credit card system, and then you will have a loan system. So the credit card system would be built in a way that customer is identified using a different nomenclature, and the loan system will identify customer using a different nomenclature. And it could have, the length could be different. Here the length could be different. The easy thing could be, hey, shouldn't you be referring to a customer master? Yeah, ideally that's true, but not all organizations have a customer master from day one. So if you're starting bottoms up, building greenfield is much more easier. But there are legacy systems where these are not standardized. Address. Some of the systems might have three fields. Some of the other systems might have 6 fields. You could have address 1, address 2. So you need, the level of standardization across data is just immense, right? I think trying to standardize data is, having tried that, done that, is the most painful part. Is mind-bogglingly complex, but very important, right? Then application specific definition. We spoke about that. Open account in, say, open account or an account number in cards. If you're a primary and a secondary, you might be still treated as a single client in the card system. But when you look at the account database, you'll have 2 entries. So you'll have I'll have an entry, and my spouse will have yet another entry. So these are treated as 2 different entries. The other thing is also the vagaries of system. Take insurance, for example. It's very country specific. So each country might have a version of how the insurance data is structured, because obviously the insurance policies are tailor-made to suit the respective country. So asking people to give a standard format is plainly just next to impossible. Difficult to find and understand data. Yeah, so that's also true. Given the vastness of data, it's easier said than done to identify people who are truly proficient. You find very few experts. People really need to spend time with the system to understand the nuances. So it is a tough job, and finding these people are extremely rare. Now while we talk about data governance, we spoke about some of the challenges. The corollary is the cost of misunderstanding or misreporting this is extremely high. Meaning to say, and that's the irony. And it's not that people are not aware. People are aware that you might miss your standard, you might not report your numbers correctly, it might lead to penalties, but people are still do not pay attention, purely like I said, purely for reasons well known to them. So there are, like I told you, fines, people have lost their jobs, and there is so much of rework involved. So there is a humongous amount of cost associated. So I would urge everyone listening into this call to take data governance seriously. And for those thinking of making a career, trust me, it's one job. I know it's painful, but that will always be in demand. That's always in demand. Right. So what are the skills do you need from a governance perspective? What kind of skills? It's an often overlooked aspect. We spoke about it, right? The least glamorous amongst the path you choose, but probably the most important. It improves reliability, confidence, and trust in data being used. So imagine you are a data scientist who's playing with data and you found out something pretty exciting and you want to share this with the CEO and the board. And imagine if you didn't have trust, or the CEO or the board didn't trust your data. So even though you found something exciting, unfortunate part is the data cannot be relied upon. So it's even more imperative that you have good governance processes so that the upstream value that you generate from it is much more authentic and people are able to appreciate what you bring to the table. Yeah, the skill is about less technical. The data engineering part, you saw a need for deep technical skills. This is more process oriented with a keen eye for detail. You need to really be a little bit patient in this area. You need to really you need to have a sense of smell and an eye for detail. You need to dot the i's and cross the t's here. Yeah, so good domain and system knowledge. So it's not that you're not technical doesn't mean you don't know stuff. You should know, for example, how data lineage, data provenance work, how does metadata work, how do I do data tagging, and all these aspects are extremely important. So you do need to be a little bit technical, but more techno-functional, and you need to know your domain and system knowledge. The last but most important point, I kept saying why there will always be jobs for data governance. As much as you automate governance and platform and security, you'll always need people to help you to keep us out of jail, right? So meaning to say, this was told by a former colleague of mine who says our job is so important that we keep rest of the bank out of jail, and which is so very true, right? So people don't understand the importance. So the only way you can emphasize the importance is, hey, if you don't want to go to jail, you better do what I do. So sometimes the stick works. Most of the time the carrot mechanism works, but stick works most. Stick also works. Scientists and all that, right? So which is probably the most glamorous part, and which is in football parlance, I would call him the striker. Data governance is more about the defensive aspects of spoke about it yesterday. More data, as much data as possible. So collecting a treasure trove of data is extremely important. Extremely important. I couldn't emphasize on this. I couldn't overemphasize. You need to have a rich amount of data. Then you need to obviously transform. You should know how to play with the data. You need to label. You need to aggregate. You need to find patterns. So all these are extremely important. And then you need to apply in the hierarchy of needs. And only then the whole AI, machine learning, or whatever you want to do with the data comes in. But as I was preparing this, right, I saw something that's missing. And I would rate that number one, which is basically executive buy-in and sponsorship and the people aspect. As much as data science is pretty niche and glamorous and everyone wants to always go towards it, the reason that I have told that this is probably the most important, or why I talk about it, is because if you didn't have executive sponsorship, you wouldn't have people to back you, because you're starting off on something that doesn't have any outcome. So basically you're playing with data. What you might think about is, how can I take this and show some meaningful output? So the whole idea is, unless you have executive buy-in and sponsorship from the senior most levels, they wouldn't give you the path to fail, because obviously you need to fail before you succeed. And in most of the data projects, there are more failures than success. It's like VCs betting on startups. You would bet on multiple outcomes, but yet one will be successful, and that one will be a game changer, because you're all exploring data. You wouldn't know what the final outcome is. So executive buy-in and sponsorship is extremely important. Yeah, so we'll talk about data analysts and data scientists. So while data scientist is data analyst is the junior form, the data scientists are what I would call the more senior roles that are associated. So many people have asked me, what's the difference? So you start off. So it's not a hard difference. Does it mean that the data analyst doesn't do predictive modeling? No, the answer is no. But this is more to give some clarity so that you understand the junior folks deal with basic programming. So you start off, right? And once you're familiar, obviously then the sooner you learn the ropes, the faster you be. Of course, you need to have good skills over Python, R, SAS, these kind of tools. But yeah, the world of data scientists is all about discovery, preparation, model planning, model building, regression model, random forest, stochastic models. So seeing what kind of models, how do I use it? It's not about just taking a variable and trying to fit it into a model, because 90% of people approach the problem saying which model to use. That's a very wrong way of approaching. Trying to understand what the problem is the most fundamental aspect of data science. You need to spend time understanding, exploring, having that conversation, then jump into the data preparation. The whole part is data scientists in a way are also like programmers. They love to open the code and start writing code, right? They love to do that. So I think spending time understanding the problem is extremely important. This is again a very often asked question. What is the difference between business intelligence and data science? Is it same, different? Look, if I use a quadrant of known and unknown, right? Data science, I would put it on the top right, which is the unknown. Basically, you're given data and you're going to find patterns, you're going to find output that no one has seen before. So your business intelligence is you're asking questions, you're given data, and you're going to find the answer for those questions. So meaning to say, you start off with trying to find out an answer for a question someone has asked or for a question that you have in mind. So meaning to say, you can do analytics. So meaning to say, you can have an idea of what you want to approach for, what kind of data is needed, how do I solve this problem. Whereas like a DNA sequencing, right? So for a new microbe or for like COVID, how do I sequence it? It's an unknown, right? So you're going to take the data points and then sequence it all together. So data science is all about playing in the unknown area, whereas business intelligence is about the known unknowns. So basically, you have a question and you try to find the answer. Right. What kind of skills do you need for data scientists? Right. So data scientist is like a multi-skilled person. So he or she cannot just say that I know a couple of programming languages, I'm a data scientist. Primarily, I think statistics, a good experience in statistics is very important. It's not necessary that you need to have all these skills again, but do understand at some point of time you need to develop those. So you might not have a background in statistics, but you should know statistics. You should have studied mathematics, and at some point of time you want to be a data scientist because you will be doing a lot of statistics. You will be using a lot of models. You should so understand what regression is, how to find the correlation coefficient, all those things. Of course, programming, I don't need to tell you, it's very important, it's a given. You don't need deep engineering, but you need good programming skills for these. You need good business domain knowledge. And I think communication and storytelling is extremely important. And as much as I just can't emphasize on this, I've met some extremely smart people who can connect data, but who cannot explain what they have found. So unfortunately, they fail at the last mile. So you need to really have a good grasp of not only finding outcomes, but also the ability to communicate the outcome in a manner that people can buy what you're saying. What are some of the characteristics? While I spoke about skills, right? So I think data scientists should be extremely curious. They should demonstrate curiosity, because obviously anyone with data should be curious, because you want to know what's happening, because data should provoke you, data should force you to think. So data scientists should look at data. Problem splitting capabilities, very important, right? When you give a problem, you need to break that down into pieces, because data scientists generally are given a big wide space and you're asked to play on that. So it's very important that you break down the problem into smaller parts and then start playing with it. Yeah, once you split the problem, you should also have the ability to transform that. And business master, I think you already spoke about that. Business and domain knowledge is very important. One of the key aspects of data is it's not a broad field, ladies and gentlemen. It is something that's niche, but it's small also. In the greater scheme of things, data is just an iota, right, at the end of the day. So there is always bound to be overlaps between the roles that you do, and more so in the data space. And yesterday I was still telling you, and again I keep re-emphasizing, the boundaries between the data engineers, the technologists, and data scientists is already thin, and it's becoming thinner. And if you take the role of data scientist, if you look at, like I said, what are the skills needed, etc., data science, I kind of put them in the middle. But what I've tried to do here is talk about what an engineer does on a daily basis versus what a data scientist would do on a daily basis. This is not exactly your daily list of tasks, but again, if you look at the task on the left, which is from an engineer standpoint, it is more oriented towards the technology domain, which is basically developing, construct, and test and maintain the architecture. You discover new data sources for acquisition. Even the data scientists can do that, but you are more close to the source system, so you kind of work with them. And then your job is to do the plumbing, which is to ensure how do I ensure that this data flows seamlessly for this person to consume. So there are. So we've come to the last role, and again, I have to be honest with you. While I played each of the other three roles in some form, shape, size in my career, and I can talk about them in detail. And this is one role that I have not done, but I thought it's nevertheless pretty important. But I do work with a lot of people who have data startups. A lot of my classmates and college mates have startups, and there are some small differences which I'll talk about in the next slide with regard to a traditional startup. So let's talk about data startup. So if you are intent to do a data startup, I think the time is prime. It's a fantastic time to talk about it. There are of course challenges, but why? Obviously, cloud has just come in. There is an explosion of data, and Crunchbase says there are 8,705 startups that are listed. Right? They rely on machine learning, and this is data is as of Q2 2019. So 2019 data is still not, sorry, this 2018 data, 2019 data I still don't have. So, but still, nevertheless, this is a very important set of numbers. 83% of the startups, data-focused startups, have only 3 funding rounds. And what does that mean? They are very early stage. All these have just been founded, right? And artificial intelligence companies raised 9.3 billion in 2018. That's a humongous amount of money, and that's a 72% increase. And I'm sure 2019, without even knowing the numbers, I can tell you it will be far higher. 2020, probably due to COVID, it could be a little bit more stressed, but 2019, it could be higher. And very importantly, AI-based patents are the fastest growing in the global category, reaching a CAGR of 29.3%, right? So data startups, much in vogue, great idea. And if you have some great ideas that you want to commercialize, go for it. So, like I said, while I'm not an authority on startups, I thought I'll share some ideas on how data startups would differ from a traditional startup, right? A traditional startup, the whole, apart from the product market fit, people generally talk terms like that and then say, hey, you need to disrupt the market. Data is not about disruption. Very, very important. Data is not about disruption. It's about empowerment. And I'll tell you why. If you take any organization, they already have data with them. So if you tell them, I have this great new software, give me your data, I'll take it out, I'll do something, and then you need to take it back. That ain't happening. Given all the privacy, secrecy laws, and the fact that the data is the true asset, I don't want to share my data. So the whole thing is, how can your tool or your software work with my data in my ecosystem? Extremely important. That's why I used, it's not about disruption. Yeah, you might think that it's a disruptive application, fair enough, but it's not about saying, taking something out and figuring something to do and then giving you the output back. It's about empowerment. Very, very important. So the ability for startups, if you're doing a startup, to blend into the ecosystem, data ecosystem, is going to be extremely important. So this is a bit, I thought hard and long about it, but I thought I should put this point. And I serve a big enough market. Doesn't mean you should spread yourself thin. Again, it's slightly contradictory to a normal startup that says just focus on a small market. Why I'm trying to tell you this is, take for example, a simple scanning solution. If you use OCR and if it does work great on English data, that's good. But China has Chinese characters, Japan has kana and kanji, and if your OCR software cannot be used there, so you should know your limitation that you will only be playing in this space. So it's very important, right? And the same holds good for startups that happen in China. So in India also, if you have forms that are in Hindi and you want to digitize, so you should have an OCR that can be language agnostic. So when I say serve a big enough market, it's not about the number of markets. And again, I want to be cautious, but be specific on that. It's about the space of data that you can cover. Very important. Yeah, so this is because numbers are just no longer enough. The ability to correlate these numbers and then actually tell you what they actually do. For those who attended my presentation yesterday, Silent 8 was one of the startups I spoke about in the name screening, right? What was so special about it is not automating the name screening process. The ability to give a narrative and then say how it works was the differentiator. There's yet another company called HyperAnna. It's extremely niche. Why? You can actually talk to the software and then say, "Hi Anna, tell me who are my top 10 customers." You don't even need to type. So the moment you do that, so the software works behind and then gives you a narrative again. So those are the companies that will make a difference in future, right? So this I thought, while this is not an exhaustive list, but I thought from a startup point, it will be very interesting. So the last point is a very interesting anecdote that I want to share with you. So Anant Bharadwaj is the CEO of Instabase. It's a data-focused startup headquartered in San Francisco. It's a unicorn. Anant is a good friend of mine, so I invited him over to speak to my management team when we had our offsite in January. And I think so we wanted to talk about how startups function, right? So the first point he made was he said, in a startup, transparency is brutal. So we were taken aback. So I asked him, what do you mean, Anand? What do you mean transparency is brutal? And he said, everything that happens is kept transparent to every employee. This might work well in a startup, but not in a large organization like us, obviously, where you need to have the necessary walls. And he was giving examples of how he had given how the company's funding rounds, hiring process, whom they are hiring, is all open on Slack. So people can log in and anyone can see and comment on it, any employee. So decisions on what snacks to buy, decisions on whether you want to work from home, what are the company policies, everything is up for debate, right? So it's pretty open and dynamic. It doesn't mean people prolong, but people participate. And if someone doesn't like someone being hired, you can be pretty open there. So, and this stuck with me. So transparency is brutal. So if you are thinking of having a startup, I've not only Anand, but many of the startup CEOs whom I've spoken to have this mantra that you need to be extremely transparent. Right, we are coming towards the end of the presentation. So we'll talk about how, and I'll answer some questions after this. So one of the key things about data is that you all know that it changes the basis of competition. I think having sat through a presentation for 2 days, you should, if you're not convinced now, you better be convinced that data changes the world, right? But what is important is not about you or me realizing that. You need a whole ecosystem to partner and to enable to make this happen. And in that way, Peter Altmaier was a senior advisor in Angela Merkel's. I think he's still around, but probably I don't know. But he's a senior advisor in Angela Merkel's cabinet. And why I really like this statement is, Germans are famous for producing cars, BMWs, the Mercedes, the Daimlers, the Volkswagen. All these are from Germany, right? And so they realized that 50 to 60% of the car, we spoke about these examples yesterday, are becoming digital. And he said, if we don't, as Germans, innovate, and if we don't re-educate and retrain our employees, we will be only fitting tires. And today, the Mercedes and the BMWs, which are generated from Germany, still have the software, everything done out of Germany. So meaning to say that existing workforce have been upskilled. This is a fantastic example of how even government should play an active role in driving adoption and making sure that every person is upskilled. The old model, so the competitive advantage was in physical engineering capabilities, right? So if someone said, I could build a locomotive engine and then I could transport goods and I would rule the world because I could have access to goods and then I could transport it to various locations and then I could make sense out of it. The new model, the competitive advantage, engineering is still very important. But of course, it shifts towards data and software, and you need to combine that with engineering. You got IoT, you got sensors, you got data, you got cyber, you got a lot of things happening. So this is how the new world is going. So these are my concluding thoughts. I think we've spoken about this enough. The line between IT and technology is disappearing, especially in the field of data. Data will be probably one of the domains where it will thin down pretty much faster than anywhere else. Extremely, extremely important. Focus more on the what than the how. The biggest challenge in data is understanding what you're trying to solve for, because 90% of the 90% of the time we don't know what the answer is. So even if you take the case of business intelligence, even though your colleague or CEO asks you a question, it might not actually, the data might not be representative of the question he asked. So you should be able to understand from the data and try to understand what you're trying to solve for. Extremely important. Don't jump into the answer. Don't immediately say let's use R or Scala or Python to solve the problem. And I still see this often being repeated. We had this fantastic example about target that I told you yesterday. And how you need to, while you need to understand your clients and you need to understand the client DNA, you should also draw a line between how intrusive you are and where you're actually making a recommendation. Right now, the world knows if your data is digital, the world knows everything about you. You can Google your name and people can find you everywhere and they can construct a DNA. But banks can do that more so with your data. If you bank with a particular bank, now almost every bank has a client DNA. But again, for organizations, not only banks, retailers, how much do I recommend products? How much do I understand my clients? How much do I make a recommendation? And how much, how do I take care to ensure that I don't intrude on his or her privacy? Right? So very, very important. This for me is something, and I hope through courses like these and other and good institutes like the IITs and ISCs and other top colleges in India and the world, people understand that you need to have data tailored courses. And more importantly, is the pace of teaching suited to the pace of change in this space. This space is extremely dynamic. So in the good old days, like I said, you could afford to do a 6-month course in Java, take a Java certificate or a C certificate, become a developer. I think the whole teaching mechanism itself should change. When I say mechanism, it's about what you teach, right? Again, try to understand what you're trying to do. How do you teach engineering skills? How do you teach open source? It's not about learning open source technologies. How do you teach open source technologies to work in a cloud environment? How can you make sure that you teach people to give back to open source? How can you teach the importance of contribution? So I think schools and universities, some of them have started, but I think they should become more mainstream. In every area, life always continues to teach you, right? So you're a student, so be prepared to be a lifelong learner. But in data field, it's paramount. The same data, there have been multiple times when I've slept over problems, when you just had 3 or 4 variables and you wouldn't have the answer. The next day morning, you would have the answer staring at you. So it's the same data that you see today would look very, very different tomorrow. So be prepared to have an open mind to be a lifelong learner. The last is a very famous poem that I really love. It's by Doug Malloch, and it's a very simple poem. Be a pine on the mountain or a scrub in the valley, but be. So essentially, you could be a data engineer or a data scientist, or you could be a CDO or a CEO or a global head, and you can have fancy titles, right? But the key thing is you should have passion, and you would really want to be part of the data ecosystem, and you want to make a meaningful impact. So any path you choose, I think you'll definitely be successful. Right. How did we do on time today? Not bad. Much better than yesterday. So we'll move to some good Q&A, and hopefully I'll be able to answer some questions today. So hope you have sent your questions. So let me just open it up. Wow, a lot of questions. So let's start one by one. I'll try to see if I've answered and then go slow. How should we, from Avdut in Pune, how should we chart a learning path so as to be a competent data analyst? Which languages, software? I think I answered this question. Prospects of mechanical engineer in this field. How should they prepare? Look, I don't think you need a computer engineering certificate or degree to be successful in this. Like I said, if you're a mechanical engineer, I think you'll be even more successful because data engineering field requires deep engineering skills. You'll be able to connect the dots better. Of course, you must have seen, prepare yourself with good open source technologies, prepare yourself with a good understanding of the data ecosystem. It's not hard to fathom these, pretty easy. But yeah, I would also recommend that you look at courses like Coursera, Udemy, Pluralsight. These are online courses. Learning data science is far more easier nowadays than what it was before, right? So knowledge in general is far more accessible. What is important is your attitude and your ability to pick up those. So in most emerging startups, this is from Preetham in Chennai, in most emerging startups, there is a necessity of a data engineer who can help in delivering stats and trends in that particular field. What all fields are expected to be present scenario to require a data analyst? I think we answered that. What is the key difference between a data scientist and data engineer? Yes, I had a slide on that. I hope you're paying attention. So it's good that we preempted that and that question is there. What is the difference between data analyst and actuarial science? Actuarial science is actually dealing with insurance modeling, right? So that also deals with a lot of data and modeling, but its specific focus is on insurance modeling. So life expectancy, what do you do with, how do you get funds and how do you take insurance premiums, distribute? So that's what is actuarial science. There are many automated data analytics tools in the market. How effective they are in real world? Fair question. Arun Singh Guleria from Gwalior. Yeah, so that's very fair. As you saw the ecosystem, there are tons. You're absolutely right. So if you try to do an open source search, almost every other day there's a new source that started up, and people say, even if you take a simple thing like Elastic, I spoke about as a powerful tool. Between Elastic and Solar is also a search tool from Apache, and you'll have fans of Elastic, fans of Solar. Unfortunately, with the explosion of data and the explosion of new technologies, the reality is that you have a variety of tools, and that's why engineering is even more important. Which tools do I choose? How do I engineer? And the most important thing is not about changing the platform repeatedly. It's about making sure you have a robust platform which is open architected and which you can scale. I'm doing my MSc statistics, sir. How could I further make a move in my career in data analytics? Wow, you're doing the right job, my friend. I mean, the right degree. So this is Archana Jeevaraj. Ma'am, sorry, not sir, but you're doing the right thing. So MSc statistics is a fantastic course. I think if you do statistics, you could start off as a data analyst. I hope you saw the skills. Brush up your skills on Python, brush up your skills on R. Modeling should be a breeze for you. But if you are good with these, I mean, you start off as a data analyst. Like I said, don't try to immediately look for titles or fancy jobs. Start wherever you are, where you can create a positive impact, right? And you'll be good. You'll do fantastically well. How do finance background get into a data analyst? This is from Zaid Ahmed. Oh yeah, finance is definitely, I mean, you should be pretty good with numbers, and finance professionals would do fantastically well as data analysts. And when I say data analyst, your domain should be finance. So you should know all about GL reconciliation. So you should know how the chart fields work. So basically, what are the various chart fields, and how do I pass adjusts, and then how does financial reconciliation happen across multiple systems? And I mean, any knowledge that you have there, you need to align yourself to the right business. So if your specialization is finance, then start off being a finance data analyst. Having done finance, and if you try to be, say, an internet marketing data analyst, that wouldn't help, right? So use your domain knowledge to your advantage. Data analysis is all about domain knowledge. So as long as you have a good domain knowledge, you'll be successful data analyst in any domain you choose. So this is from Mumbai. Path. I'm interested to go into business analytics. How to differentiate the job description of data science, I think we saw that. So business analysis is more. So the difference between data analyst and business analyst is data analyst focuses more on the data aspects of it. Meaning to say, like I said, business analysis is more with the operational aspects of data. So if you take a credit card system, a business analyst would know how the card's data is linked. So he would know, for example, what is total cash spent. It's made up of local cash spend plus international cash spend, and it's also made up of card spend. So these nuances would be well known by a business analyst. A data analyst would know the total cash spend has three fields, and if you drill down, you can get this. These are the data elements, and this is used in the reporting of the total outstanding balance of a client in the reports that is used for this financial reporting. So the difference is a business analyst focuses more on the upstream processes. A data analyst focuses more on the usage of the data. I hope that example helped. What are the one skills you? I think we answered that. I am an MBA from IIM. MBA from IIM versus MSc in data analytics. Look, you can't compare degrees, right? I think a degree is a passport, is just like a passport. How you utilize the degree is to just get a foothold. And again, pardon me for saying this in this forum, but I think degrees will become irrelevant over a period of time, right? The reality is, while degrees are important, I'm not saying they are not. Good college gives you a good network, and exposure is extremely important. Please immediately don't go and think that degrees are not. But if you truly want to make your career successful, the knowledge that you exhibit, the passion and the attitude is what people look for. And already Googles of the world, the Amazons of the world, they hire people with these attitudes. So degrees have not been made a prerequisite. So I wouldn't compare MBA from IIM versus MSc. I mean, both are very good degrees in data science. I mean, make the best use of it. Scope of data science in health as a medical graduate from India. Oh, brilliant. I think health sciences is something that's just exploding, and that's probably got the most complex data, because how do you do DNA sequencing, genome sequencing? Now the blood plasma is all taken and stored. How do you apply that? And if you all thought that was biology, probably you're right, but the actual thing is all data and science. So it was surprising. So I'm not an expert on that, but I have a friend of mine who is a biochemist, but actually a data scientist. So it's a very, very exciting field, but you have a tremendous future. It's a very niche skill. If you're a doctor looking to move to data science, God bless you. I think you'll do phenomenally well. Okay. Shrikala, what are the different skill components that are sought after by employers? I just told you. I think we spoke about that. This is from Rudrani. What do you suggest for a mid-career change in data analytics? What do you mean by mid-career change? If you got good exposure, like I said to an earlier question, if you have good domain experience, move to that particular domain as a data analyst. If you have good coding experience, you should move as a data engineer. But if you have good knowledge on processes and how they work, you could move into governance. I am a BE mechanical engineer. Should I do masters in regarding anything, or just join as data scientist? Look, again, I think we've spoken about it. A qualification is good, but it's about the knowledge that you develop and what you want to specialize. You can choose one of the three parts I spoke about: as a data engineer, as a data scientist, or as a data governance specialist. Okay, how much time you got? Okay, let's take some more questions. How to improve, this is from Naveen, how to improve communication skills, soft skills, and career guidance. How do you improve communication skills? read a lot of books. I think any form of book in shape, size, so be it a novel or, I mean, reading, I think, really gives you a good exercise of mind. So really helps. I personally gained from it, but I think you don't need to restrict yourself to novels. So you can read any material, and surely it helps you to improve your communication. What are the technologies one needs to have as a beginner? I think we've answered that. Currently, I'm working as a business analyst in a top MNC. So if you can guide what more should I do to get a better future, I hope this presentation you saw, I mean, if you're already working in a top MNC as a business analyst, you want to move into the field of data science, it should be pretty easy for you. And I'm sure, given that you're already in that company, they would definitely give you preference. Will it be prudent to do a master's in statistics, say Master of Science in Statistics in NUS? That's my school. So Vijay from Chennai. Or suggest another master degree. Look, like again, a degree in statistics always helps. So I think whether it's NUS or any other school, again, what I just said earlier, the holds good. It's not about the quality of, it's not about having a degree from a reputed university. What is important is your depth of knowledge. So yeah, so it's very important. So if you already have good basic bachelor's and you have good tremendous exposure in a particular domain, and you're pretty and you have pretty niche skills, like you saw, you're pretty proficient with open source, you're pretty good with modeling, then I mean, I wouldn't. But again, having said that, there are some companies that really look for skills that are deep, and Kaggle, I don't know how many of you are aware, this used to conduct a lot of quizzes, and I know a friend of mine who used to recruit based on Kaggle participation. So so Kaggle is where you can go and do a lot of data science quizzes on your own. So look for those areas. So that can also help you to boost. Python compared to Java, it is difficult. Hey, look, I don't think Python is or Java is difficult. See, coding itself is becoming more and more abstract. When many of us started off, we used to write, used to handle memory exceptions, you used to handle code dumps, and you used to really work at low level, right? But nowadays, I mean, containerization has just changed the world, right? I mean, if you tell me it's tough, I would say coding has become far more easier, far more easier. Uh, Coding in Scala, coding in Python, I mean, it's a breeze. So I respectfully disagree to the statement that it's tough. So as you start doing, but of course you need a passion for it, right? So how agriculture? This is a good person, Dr. Gangai Selvi from Tamil Nadu Agriculture University. How does big data analytics used in a crop yield prediction in agriculture? Wow, I don't know if you attended my lecture yesterday, but we spoke about an example of John Deere, JOHNDEERE. So um, probably I won't give you a long answer because I'll be eating up into other person's time, but please read about John Deere's transformation. It moved from an agricultural company to an AI company. So they used something called precision agriculture. They used precision herbicide spraying. They acquired a company that specialized in this. So they are the world leaders in precision farming and autonomous farming. So this is Gangai Selvi. Please, I urge you to read that as a case study, and that's a great insight. How did you learn data analytics at this level? You spend 20 years, you'll all learn. So I think it's just a question of time. Wow, these questions keep coming. Let's see. Yeah, so I'll probably do another 6-7 minutes and then I'll stop. I'm doing a final year undergraduate in statistics. Can I continue a master's in statistics or data science? Which pays off? If you've got a bachelor's in statistics, I would say do a master's in data science. It gives you a different flavor. So yeah, so I would definitely recommend that you do data science. Basic statistics is more than enough, and you would know more or less how statistics is used in this. So pretty much okay. Good evening. What is the role of cybersecurity nowadays? Does it have a major role in this other job? Yes, cybersecurity is extremely hot, and I think probably you need different session to talk about it. I'm not an expert on that field. I know the workings of it, but it's an extremely hot field. CISOs are very much in demand. If you ask me, probably if there's something that's much hotter, or if not as hot as data science, it is cybersecurity. Can you please share your experience in Standard Chartered where the data analytics have been used in a positive manner? I spoke about a lot of use cases yesterday, my friend, but again, try to Google Standard Chartered Silent 8. It's available in public domain. You can Google that and then see. Can we teach data science program without how problem solving? Answer most of these questions. They are a bit of a repeat, so pardon me if I call it out loud, because I sometimes these questions are repeated. So as I scroll through it, I'll just read up and then I'll pass if I have answered those. What is the scope of data science in India? And this is from Mumbai. So I look, data science in India is extremely hot, and data science in India is probably I would say the hottest job. Yeah, like cybersecurity, right? So, and the reason I'll tell you why. India is a market that has still, and world in general, has not harnessed data science. We're just scratching the surface. As much as we talk about data science in glowing terms, I think as an industry, we're just scratching the surface. We have not done anything. So there's so much to do. It's just the tip of the iceberg, and we have tremendous opportunities in any domain you choose. So data science in general. So data science is generally associated with domain. That's very important, right? So if it's a healthcare, or if it's in retail, or if it's in banking, or if it's in insurance, you need to know which domain you want to specialize in, especially data science. Data engineering can be more horizontal and it can cut across domain, but data science is more specialized. Of course, but if you are a good data scientist, you can learn, your skills are transferable across industries. But in general, data science is very domain specific. From Singapore, do you intend to start into data startup? I can't answer that in public domain, but you never know. So, is there any scope in sports analytics? How to go about? Oh, brilliant question, Rihan. That's sports is something that I love, and this has been a question that I've also been grappling with. And let me give you two answers on this. Sports analytics is very niche, right? And today, NBA, the National Basketball Association, which is the premier basketball league in use in America, has a dedicated data science team. Every team has a dedicated data science team, and they are probably one of the most highest paid. And even the coaches listen to them. So actually, the game of basketball, I don't know how many of you follow basketball, but let me give you the example. Historically, basketball was thought to be a tall guy sport, right? Or tall girl sport. If you're very tall, you could stand near the basket and just put the ball in. But Steph Curry, sweet shooting guard, and he wasn't that tall compared to the normal players, revolutionized the game. It was actually done with this. Of course, he's a supremely talented athlete, but that was done with the help of analytics. So the whole idea was the whole game of basketball was played around the net. So he said, why don't I stretch the floor analytics and then say, let me make it positionless and start shooting the ball from anywhere. So imagine, so the whole concept was get the ball as close to the basket and then put it in. That's the easiest way because you're closest to the distance. And he revolutionized the sport by saying, let me start shooting the ball from any spot on the court. So that to me was, that's a great example of how data science revolutionized sports. And I can talk about in cricket. There I can give you tons of examples. So, but I mean, that will overtake this. But you can contact me. Yeah, that's a fantastic question. Sports analytics, if you're planning a career, go for it, my friend. It's a brilliant, brilliant field. How to start a career? Okay. No questions is a question, so that's good. Is Tableau good to learn or not? So Tableau is a presentation tool. I won't. It's pretty easy and intuitive. I don't think you need a certification Tableau. You can pick up the skills in a day or two. It's good to learn. Nothing wrong about it. But like I said, nowadays the whole concept is about having an arsenal of tools. Whether you're a data engineer, whether you're a data scientist, if you just say I know a particular tool, that's not good. It's not good enough. It's good, but not good enough. Hello, sir. I'm an automotive engineer keen on learning data science, and how do I implicate the same in automotive domain? My friend, you're in the right area. You see driverless cars. You see all the future of vehicles. You will be in huge demand, my friend. If you're an automotive engineer and if you want to make a career switch, of course you need to learn the ropes of data science. It's a hard grind. I would suggest you work for an automotive company as a data analyst at the lowest level. But of course, you need to equip yourself with the skill. But in a short span of time, you will fly high. I don't have any doubt on that. Use of classification algorithms in real world. Can you give an example? A simple example would be a classification of cats, right? If you want to train a computer on identifying a cat, you show various pictures of cat, and then you also show them a picture of a tiger, which is also a form of a cat. It's a large cat, right? You call it. So it's all about training. It's all about tagging, and then automatically the system learns. So that's an example of a classification algorithm. Okay, so I think we are coming close to the end. I'll answer the last two questions and then I'll stop. Agriculture student, there's yet another question I just answered. Mrs. Gangai Selvi. Is a PhD necessary for data scientist role? Absolutely not, my friend. Absolutely not. I can tell that with hand to heart. You don't need to be a PhD to, PhD is a given respect, and obviously they have slogged it out and you need to respect the qualification. But for you to be a data scientist, like I said, I hope you saw my presentation, what's the kind of skills you need. PhD is definitely not necessary. Role of AI and ML in finance, we answered that. Okay, so that brings me to the end of this presentation. Thank you for your time. I hope I've been able to answer some questions today. I couldn't cover yesterday, but again, thanks for listening and dialing in. Good night.